Okay, this lesson is to go over the law of sines and the law of cosines in geometry. So first of all, the law of sines and law of cosine formulas are here, and we'll go over them in more detail as we go over the examples. But one thing that you really need to know or be aware of is that the letters here matter. If they're capital letters, then they refer to angles. And if they're lowercase letters, then they refer to sides. And those sides are opposite of the angles. And so angle A always is opposite of side A, and angle C is opposite of side C, and angle B is opposite of side B. So you need to pay attention to the orientation of where the sides and the angles are in the diagram. Sometimes they call them DEF or XYZ or whatever, but basically the letters correspond with each other. So the first thing we're going to do is look at the law of sines. And the law of sines is used whenever you have some information known about a triangle. In this case, you have two angles and two sides, but since it's not a right triangle, you can't use the Pythagorean theorem. And so how else are you supposed to solve for the unknown sides or angles? Well, you can solve for the unknown angle if you have two of them, because you can use the triangle sum theorem. But like in this case, in some of the cases, you don't have two angles. So let's look for the law of sines. The law of sines is used when you either have two angles and one side, or two sides and one angle. Again, they have to be corresponding, so it matters where they are in the diagram. So if we look at our first example, then it looks like we have two angles, and you have some side information. So across from angle B, you don't have side B, and that's what you want. And across from angle C, you do have side C. So because you have three of the four pieces of information, then you can use the proportion in order to solve it. And they ask you to round to the nearest tenth. So because of that, we're going to use the C relationships and the CB relationships, like we said, instead of a proportion. And be sure that your calculator is in the correct mode. So you want to go to your mode and then ensure that you're in degree mode. Otherwise, all of your answers will be wrong. So anyway, you do that, and then you cross multiply. And when you cross multiply, you have B times the sine of 45 is equal to 30 times sine of 74. Since we're solving for B, then we want to divide by the sine of 45 degrees so that we can solve and isolate B. It asks us to round to the nearest tenth, and so that's how we got that information. So let me just plug this in the calculator so you can kind of see how it would work. So you literally would just type in 30 sine of 74, and since we've already been in the degrees, then we know that it'll be correct, and we're dividing it by the sine of 45 degrees, and whenever you type it all in, you'll get 40.78, which rounds to 40.8. It's a side measure, so we don't need a degree symbol. The second example is similar, but the problem with the second example is that you have information about side E, but you don't have angle E. And for the law of sines to work, you have to have the angle and the side relationship across from each other. In order to solve for D, you can use angle D and side D, but you have to use the triangle sum theorem to figure out what angle E is first, because you need the E angle relationship and the E side relationship to plug into the law of sines formula. So I wrote some information down about that. So we're going to use E and D. So we went ahead and found out that the angle measure of E is 58 degrees by taking 180 and subtracting the other two angles. Then we cross multiply. And after we cross multiply, we divide by the sine of 58 to isolate D, and we find that D is 28. It is a side length, and so we don't need a degree measure or anything like that. All right, so let's do a few more practice problems. So down here we have several examples, 1, 2, 3, 4, 5, and 6. So look at triangle number 1 first, of the triangle in number 1. We do have an angle and an opposite side measure, so this would be the sine of 80 divided by x is equal to the sine of 40 divided by 12. That's the law of sines. And again, we don't have letters here or sides here, but if you just remember that the law of sines are relating an angle to the opposite side and an angle to the opposite side. It's always sines. That's why it's called the law of sines. So you can't use tangent or cosine or any of the other trigonometric functions with this. Number 2, you would solve it by saying the sine of 52 divided by x is equal to the sine of this angle divided by 20. And the reason is because you have to use the angle side relationship. To get this unknown angle, you just take 180 degrees and subtract the other two angle measures, and you'll have this one. For number 3, the sine of 84 divided by x is equal to the sine of this angle divided by 16. Again, because you need to have that angle relationship for the law of sines. You can use 180 and subtract. So you get the idea here. So here are the solutions. I want you to try it first and then check your answer against what's in the video. It asks you to round to the nearest tenth, and so that's what was done. Be sure all of this is written in your class notebook. That way, whenever you go to do your homework, it'll make more sense. Now, the law of sines requires that you have either two angles and one side that's opposite, or two sides and one angle that's opposite, and you can solve for that unknown information. The law of cosines is a little trickier, however, because in that case, in the law of cosines, you either have only one angle in the triangle, so you can't solve for the other two, so you can't use the law of sines, or you have no angles but all of the sides. And again, it's not a right triangle, so you can't use the Pythagorean theorem. Now, because of that, you have 3 different forms of the law of cosines. And the 3 different forms, if you'll notice, look a lot alike. The only difference is what you're missing. So in this case, I'm looking for side C, so I would use the law of cosines that solves for the side C. In this case, I want to find the measure of angle A. That's what they ask us for, the measure of angle A. So I would use the law of cosines that has the angle A in that in the formula. So let's look through this first one. So the law of cosines says find C. So that means C squared is equal to A squared plus B squared. This looks a lot like the Pythagorean theorem right here. So if we were to stop right here, it'd be a right triangle. But because it's not a right triangle, we have to add in this extra piece. So you're going to subtract 2 times A times B cosine of this angle. Remember, capital letters are angles, lowercase letters are all sides. So all of these lowercase letters indicate the sides. So this is side A, this is side B, and this is side C, and angle C. So let's plug it into the formula. So we want to find side C. So we plugged in our A, our B, our A and our B, and our angle C. And then we simplify the information as we go. Just plug it into your calculator. Keep in mind that you need to be in degree mode over here. So don't make the mistake. Some students make the mistake of not recognizing that this information over here is multiplied by the cosine. So they end up trying to add and subtract these numbers and then somehow multiply it. Don't do that. All of this is one term. So you're subtracting all of this information. So make sure that whenever you're simplifying the expression, that you keep the coefficient to the cosine of 48 degrees all together. This is one number. So you can add these two together, that's fine, but then you need to subtract the whole thing. When you get down to here, you get C squared is equal to a number, and so then you have to square root it in your calculator, and you get a number here. It asks us to round to the nearest tenth if it's a side measure, and to the nearest degree if it's a degree. So what happens if you have all these sides here, but you don't have the angle? Well, you're still going to use the same formula, but the unknown part is going to be the angle. Now, remember when we were doing our trigonometric functions last week, when you were solving for an angle, we always used the inverse functions. So instead of using sine, cosine, or tangent last week, when we were solving for an angle, we used the inverse sine, cosine, or tangent. That will be the same thing as we do now. So we'll plug in all of our side measures. In this case, we have our side measures and all of this information. What we don't have is the angle. That's the thing that's unknown. So you're going to simplify the information as you go, like square everything. All of this is going to be a coefficient to the cosine. You can combine these two terms because you can add them together, and that becomes 89. And then you still have minus 80 cosine A. So to get rid of the 89, you subtract 89 from both sides, and you get a negative number. That's okay. So you have a negative number equal a negative coefficient to cosine. So to isolate the cosine, you just divide by the negative 80. It's like a coefficient of an x. And then you get that 0.5 is equal to the cosine. Well, now we want to solve for A. So the only way to get rid of the cosine is to take the inverse cosine of both sides. And that's what we do. We take the inverse cosine of the left and the inverse cosine of the right. And the inverse cosine and cosine kind of cancel each other out, if you will. And so we get the measure of the angle A is equal to 60 degrees. They ask us to round to the nearest degree. All right, so let's look at the other examples that are in your practice sheet. So in this case, you're going to want to choose the law of cosines that solves for A, because side A is what you're looking for. So it'll be the A squared one. In this case, you're looking for angle B, so you'll use the law of cosines where the angle B is over here, and you're going to end up using the inverse cosine to solve for the angle. And you'll sub in all the other numbers. In number 3, you're looking for C, so you'll use this form of the law of cosines. And these will be provided to you on the test, or you can write them on your note card. Here we're looking for side B, so we'll use this formula. In number 5, we're looking for side A, so we'll use this formula so we can solve for side A. And then on number 6, we're looking for angle C. We'll end up using the inverse cosine, but we'll use this formula here. So if you'll practice them and then check your answers on the video, that would be best. So you use the right formula, plug in the information that you have, and then simplify. Try not to do too many simplification steps at once. I know it's tempting to do that because you feel like it's a waste of paper or a waste of time to show too many steps, and you don't necessarily have to show as many as I'm showing. But when you skip too many steps, a lot of times you can make some errors. So it's better to show a little bit more and get the right answer than be in a hurry and skip too much or do a bunch in your calculator and get the wrong answer. Here's number 3. And then number 4. And then number 5. And then number 6. Okay, use your notes and do the best you can on the homework. I'll be in on Tuesday to help you out with any questions you might have.